told that the completion of a highway construction project must be delayed because of a projected storm, then we're given certain probabilities. We're asked to find the probability the construction job will be completed on time. First, let's define some events based upon the information we're given to us, right? The two events we're interested in this. S is there is a storm. And C is the construction job will be completed on time. And they're given certain probabilities here. We're given the probability of storm is 0.6. Where is this given? Let's just see. So we're told the probabilities are 0.6 that there will be a storm. That there will be a storm. And we're told that probability that 0.85 of the construction job will be completed on time if there is no storm. So we're given the probability of C given S complement, which is 0.85. So we're given this as well. So this we're given here 0.85 that the construction job will be completed on time if there is no storm, right? So we're given this probability as well. And then we're given another probability, which is the probability 0.35. The construction will be completed on time if there is a storm. The probability C given is, right? This is the probability it will be completed on time if there is storm, right? So this is 0.35. So we're given this as well. Right, so we're given this probability as well, right? So we're given this as well. Right, so now what they want us to find is, now what we're required to find is the construction job will be completed on time probability of C. So essentially, we want to find we essentially want to find an unconditional probability, right? This is an unconditional probability, not conditioning on anything. We want a conditional probability by conditioning on mutually exclusive and collectively exhaustive events. So we want to find this unconditional probability by conditioning on mutually exclusive and collectively exhaustive events. And which events are those in this case? That there is a storm and there is not a storm, which are S and S complement, right? So we want to find this unconditional probability by conditioning on the two mutually exclusive and collectively exhaustive events, that there is a storm and there isn't a storm. So use total law of probability. Right, so use total law of probability. Right, so over here the whole idea is this: we want to find the probability that it's completed on time by, so this is an unconditional probability by conditioning on two mutually exclusive and collectively exhaustive events, which is storm and no storm. Why are they mutually exclusive? Because they both can't happen at the same time. You either have a storm or you don't have a storm. And why are they collectively exhaustive? Because these are the only two possible outcomes. You can have a storm or you can't have a storm, right? So we're going to use the total law probability here. So why does total law probability? Total law probability is used when you want to find an unconditional probability by conditioning on some mutually exclusive and collectively exhaustive events. So using total law of probability. So if we recall what total law probability is, it says that probability of A, which is an unconditional probability, can be found as probability of A given B plus probability of A given B complement, where B and B complement need to be mutually exclusive and collectively exhaustive. So this is important. You are conditioning on mutually exclusive and collectively exhaustive events. And collectively exhaustive events. So if I apply total law probability in this case, we want to find probability of C, which is going to be probability of C given S into probability of S plus probability of C given S complement into probability of S complement. And these probabilities we already have. We saw that probability of C given S is 0.35, which is this one over here. Probability of S is 0.85, this over here, plus probability of C given S complement Oh, sorry. This is 0.6, my bad. This is 0.6, right? Plus probability of C given as complement, which is this 0.85. The probability the construction job will be completed on time if there is no storm. And probability of S complement is not given to us, but we can find it from probability of S. Probability of storm is 0.6, so probability of no storm is 1 minus 0.6. So this then just turns out to be 0.51. So in this way, we can find an unconditional probability by conditioning on mutually exclusive and collectively, we can find unconditional probability by conditioning on mutually exclusive and collectively exhaustive events. Oh, sorry, no, not 0.1, it's 0.5 and this is 0.55. So in this way, we can apply total law probability to find this unconditional probability.